our goal in Chapter 3 is to learn how to graph polynomials that aren't just parabolas, that are new ones with different degrees. So first of all, I'd like to talk about what it means for a function and what its degree is. So if we have a function, let's say that the highest exponent is the n, and it has some number out in front, let's call that a. What we want to talk about is what are different properties of these functions. So what does it mean if this n, the degree of the polynomial, is odd, or if it's even? Meaning that the highest exponent, if it's odd, is a 3, a 5, a 7, a 9, that sort of thing. Or even meaning squared, 4th power, 6th power. In the previous section, we learned how to find the zeros. That means where you cross the x-axis. Now we want to talk a little bit more about different behaviors, what they're doing at what's called the ends of the graph. It's called end behavior. And in order to talk about end behavior, you have to be able to talk about whether or not a function is even or odd, because your end behavior will be different depending on if you're even or odd. For instance, odd degree polynomials have where they have the two ends of their function and going opposite directions. So if you look at the examples here, notice that one end's going down, one end's going up, one end's going down, one end's going up. Same thing for all of these that have an odd degree. In all of these, we see that it's going down first, then up second, but it could very well be the reverse, that it's going up first and then down second. So if we have an odd degree, it's going to do one of these two things. It's either going to go down then up or up then down. So the question becomes what determines which one of the two it's going to do first. Either going down first or up first is going to be the a that's out in front. So if there is a positive a out in front, it will go down first, then up second. If the a out in front is negative, then it will go up first and down second. Notice that these odd functions, though, have some very specific properties, and you do need to know these, is that they generally have symmetry about the origin, which means that if you rotate the graph by 180 degrees, their picture will stay the same. Notice also with these graphs that because they go down in one direction forever and up forever in the other direction, that means that their domain and range should be negative infinity to positive infinity if you have something that is odd. And we did talk about this briefly here, which is most of the graphs will go up from left to right, but that is only if your a is positive, the a that's out in front of your term with the highest exponent. Notice it's continuous, it doesn't have any breaks, meaning you never have to pick up your pencil to trace it, and it's increasing or decreasing on its entire domain. If the a was positive, you're increasing on the entire domain. So if your a is positive, you're increasing on the entire domain. If the a is negative, you're going to be decreasing on the entire domain. At least just to start. We'll throw in some variations on this, but this is just if you have an x cubed, and x to the 5th, with nothing added on after that. Looking at even degree polynomials, notice what you have is you have kind of the reverse. We have either both sides are going to be pointing up at the ends, or both sides are going to be pointing down. So even means that the ends of our graph are either going to be pointing in the same direction, either both up or both down. So those are your two options if you have an even degreed polynomial, meaning that the highest exponent is even. Now, if your a is positive, both ends should point, meaning a is greater than 0, both ends should point up. If the a is negative, both ends will point down. what we're seeing below is when all the A's are positive, which is why they're both pointing up on both ends. So here we've gotten our examples below that we have a positive A because there's a hidden 1 out in front, and that's why both ends are pointing up. Notice with these graphs, a lot of times you end up with symmetry about the y-axis, meaning if you cut it along the y-axis, you have the same picture on both sides. Also, notice that they still, because they go left and right forever, have a domain of negative infinity to infinity. However, the range may not be that. Notice that these graphs have a range, because they're starting at 0 and continuing up forever, have a range of 0 to infinity. Notice they're all starting at 0 and going up forever. And again, this is assuming that we're not shifting left, right, up or down, or anything crazy like that right now. And notice the graphs, at least on these pictures, are increasing. Let's see, at least for these, they won't always be like this. On the right side are increasing on the right of 0, so that would be from 0 to infinity. And that would have to be with a parentheses because we're talking about increasing and decreasing. And notice it's decreasing on the other side from negative infinity to 0. And again, with increasing and decreasing, we always use parentheses. And because our A's are all positive, that's why we see that they're rising on both ends. They're going up on both ends, but that will not always be the case. Again, it's dependent on what your A is, on if it's positive or if it's negative. And we'll go into more detail as we continue along. These are just kind of to give you a good idea of what's going on with odd versus even. We'll get more detailed and get into special cases later. Remember, if we put a negative out in front of a graph, we saw this when we did our parabolas. What did it do? It flipped our graph upside down. So if you flip a graph upside down, and just use our parabola as an example, we had our regular x squared that did this, and then if you looked at your x squared with a negative on the outside, it just flipped it upside down. What it did is it made a reflection. It flipped your graph over which axis? The x-axis. So whenever you put a negative in front of something that's outside of your function, it does flip you upside down and over the x-axis. We've also talked about this. When you have a plus or a minus on the outside of your exponent, what happens is that shifts you up or down. So it's shifted up or down depending on if it's positive or negative. Remember, if it's positive, it's going to shift you up. If it's negative, it will shift you down. We also could have a number on the inside of our exponent. If it's on the inside, though, it's going to shift you left or right. Remember, with left and right is reverse of what you would think. So left is, you're going to shift left when you actually have a positive value, and you'll have a shifted right if you actually have a negative or a minus inside. Is reverse of what you would think. Nothing new. And then we'll talk about this in more detail later, but remember that A out in front is going to determine our stretch, and it's also going to help us determine what our end behavior is doing based on if it's positive or if it's negative. So we're worried about two things: whether or not that A is positive or negative, and whether or not you have an even or an odd. So the first thing that we're going to worry about is even versus odd. And then the second thing we'll worry about is whether or not our A is positive or the A is negative. And then that will help us determine what's called the end behavior, meaning what are the graphs doing at the ends? Are they both going down? Are they both going up? Is it going one down, then one up? Or is it going one up and then one down? Those are your only options, but those are your four options that you have: 1, 2, 3, and 4. Okay, so what we want to be able to do is just look at a function's equation that's given to us and be able to figure out what the ends of the graph are doing. And when we talk about the ends, we're talking about, that's why we leave a gap in the middle of these. We're just talking about what's happening as you get closer to positive infinity on your graph, and as you get closer to negative infinity. What's happening at those ends? Are they both going up, both going down, one up, one down? What's going on? That's what we're talking about. So let's take a look at a couple examples. In this first example, the first thing that we should note is that are we dealing with an even or an odd function? And the first thing I notice is that it is even, because of the x to the 6 being the highest exponent, which means either that they're going to be both pointing up on both ends or both down because of it being even. However, what's going to tell us whether or not we're both pointing up or both pointing down is the fact that the a out in front, the 10, is positive. Because the a is positive, we're going to be pointing up on both ends, which means I'm going to choose the first one, that both ends of our graphs as we go towards negative infinity and positive infinity should be pointing up. Let's try another one. Let's take a look at B. In B, we're going to, again, first look at whether or not we're even or odd. In B, though, if you look at our highest exponent, we are looking at an x to the 7th, which means we're talking about an odd function. So what that does is narrows us down. If we've got an odd function, we've either got one up and one down in either direction. Could be the down then the up, or it could be the up then the down. Now, if we look at A, which has a 4, which is a 4 on this one, because it's positive, that means we're going to start with the traditional, which means we'll actually start going down first, and then we'll go up second, which means we're going to be looking at this first option. So we will be choosing this first option here, that it goes down then up, if A is positive. That's all. On problem C, again, we want to start out with whether or not our function is even or odd first. And on C, notice that the highest exponent is an x to the 3rd, which means we're looking at something that is, again, odd, which means we're going to be either going down then up or up then down. Because it's odd, they have to be pointing in opposite directions, and that's going to be determined by whatever number is out in front of the x cubed. Well, in this case, it's a negative, which means it's actually technically a -1 out in front. Well, because the a is negative, it means we're going to do the reverse of what's typical, which means we're actually going to start by going up first and then down second. So we're actually going to choose the second option first, that the left-hand side's going up and the right-hand side's going down. In problem D, let's take a look again. We've got to deal with even versus odd. And on this one, notice it's out of order. So the highest exponent is actually on the end. So we're going to be looking at this -10x to the 4th. So if we look at its exponent, it's x to the 4th, which is even, which means that either the ends are going to be both pointing up or both pointing down. In this case, we're going to be looking at the -10 out in front. The -10 means it's going to be flipped upside down from what's traditional, which means they should be pointing down. So because A is negative on our even here, they're both going to be pointing down on both ends. But that's it. So this is going to be a huge key in order to graph our functions here, which are going to be polynomials. It's going to be telling us what's going on at the ends of our graphs, which is really important because we've already talked about what's going on in the middle of the graphs and how to find your zeros, aka your x-intercepts. So now we have an idea of what's going on in the middle. and we have an idea of what's going on at the end. This should really, really help us.